Alright, so to get started, we are going to do our typical setup, do our imports, importing PyKX as KX, and then we can begin our notebook working with these PyKX tables. So first, how do we actually create a table? And there's a couple ways that we're going to look at in this notebook to do that. First of all, using kx.table. And with this method, we can just pass in the data that we want to create our table. So here we're going to create a table that has two columns, X and Y, and then each of those columns will have 5 rows created for it, and each of them is going to have data generated using that random method that we learned about in the previous section. So if we run this, we will have a PyKX table that contains 2 columns with 5 rows each. Now, the other way that we can create a PyKX table is by reading in a CSV file, and that will take that CSV file and directly convert it into a PyKX table for us. So depending on our situation, we have different ways that we can use to create our PyKX tables. Now, this is going to take a couple seconds to run because we are reading in 2 large CSV files here, and we'll be dealing with 2 large PyKX tables. So once our table's created, we can then start to do some exploration and pre-processing upon our table. And the first thing we'll likely want to do is say, how large is our table? How many rows in our table? How many columns does our table have? And to do that, we can use .shape. So table.shape, and this will tell us we have over 3.5 million rows and we have 12 columns in our table. And we may want to get a little bit of a closer look, so we can use the table.head method to see the first 5 rows of our table, as well as all of the columns in our table. So it's a perfect preview of what data is held here. Now, say you wanted to print, the first 100 rows, you could just do .head and put 100 here, and it will print us the first 100 rows. So what we see with this Bitcoin table, and as well with the other table, the Ethereum table that we imported, is these tables hold trading data every single minute between about August of 2017 through early 2024. So they hold the opening price, what was the high and the low price and the closing price, volume for every single minute. So that gives us an idea of the data that we're actually dealing with. And then as we move further through these sections and we start running analytics on this data, we'll be able to start to see how this data moves over time and understand what is the mean and the median, maximum, minimums, all this information, all these analytics to help us get a better understanding of this data set. Okay, so now it would be great if you can pause the video and try exercise 8, where you'll be printing the first 10 rows of a table, and then when you're done, just click reveal solution to check your work. So now let's continue our exploration of our table, and we would like to see what are all the columns held in the table. And there's 2 ways we can do this. We can do this with our pandas-like API, where we just do tab btc.columns, similar to using pandas. However, we could also do this using native PyKX functionality, using kx.q.calls, and then passing in the table that we're interested in, and this will tell us all of the columns held in our table as well. Another thing that we might want to see are the data types that are held within each column. We can do table.dtypes to see this. This will show us all of our columns and the type that are within them, and this shows us actually the atomic types that are held within these columns. Okay, so we've got a better idea of what's held in our table now, and the next thing we will want to do is try to create a new column on our table. And in this case, we're going to create a new column called date, because right now we just have timestamp, and we have a timestamp for every minute in our data set. But we don't actually have the specific date, and later on it'll be important to see the specific date of each row. So all we're going to do is do a little data type conversion here, and we're going to create a new column by saying tab BTC square brackets date, which will be the name of the new column, is equal to tab BTC of the timestamp column dot date. So we're taking this timestamp and we're going to convert it into a date and then save that in each row. So we are effectively creating a new column and then passing in for each row the specific date based on the timestamp. And we're going to do this for each of the PyKX tables, both the Bitcoin and the Ethereum datasets. So let's do a little extra cleanup here, and we're going to drop some duplicates off of each PyKX table, and we see that really, there's not any duplicates in here, which is great, but in some cases there will be duplicates, so it's good to understand how to use this drop duplicates functionality. And finally, let's take another look at our table after we've added our new column, and we can see right here we added our date column and the dates are all correctly displayed. Perfect. Now let's say we want to rename a column, and we can easily do this using tab BTC dot rename. We specify the columns that we want to rename here, so we'll take the number of trades column and just rename it to num trades, just for simplicity's sake. And then we can scroll over here and check that that is correctly displayed. Num trades, perfect. Num trades. All right, so now we know how to rename a column. So now that we've created our table and done some table exploration, we will do some table interrogation. And at this point, our goal is to understand more about our table and also to access certain values within our table that we might be interested in. So first, we're going to look at the .at accessor. And here, all we need to do is say our table .at, and then the row that we're interested in and the column that we're interested in. So this will find a value for us in a specific row and column. Next, we can use .get to get a column or columns from a table. So in this case, we may want to just return our timestamp and close column. Well, we can easily do that using table.get. If we want to understand if all of the rows in a certain column or in all of our columns are truthy values, we can use table.all to find that. And next, we can use table.any to find whether all or any of the values across a given axis have a truthy value. And we can see here that all of the columns contain truthy values except for the ignore column. Alright, go ahead, pause the video, try exercise 9, click reveal solution to check your work, and we'll see you in the indexing and filtering section next.